Welcome to The Explainer. Today, we're diving into a full-on comprehensive guide to Python. We're going to explore this whole journey together, from the absolute basics of setting up your digital workspace all the way to building real functional apps. Python is honestly incredibly valuable. I mean, it literally powers everything from data science and AI to back-end web development and everyday task automation. So whether you're entirely new to programming or you're just looking to, solidify your foundation, you're in exactly the right place. We're going to unpack these core concepts step by step. Let's make them logical and totally digestible so you can start coding with real confidence.
So here's the roadmap for our explainer today. First, Python setup and IDEs. Second, core syntax and functions. Third, object-oriented programming basics. Fourth, the PEP 8 coding style. And finally, building Python applications.
Let's kick things off with part 1, Python setup and IDEs.
Okay, so your IDE, or Integrated Development Environment, is basically your primary tool. It's your digital workbench where you write, edit, and test all your code. Now, idle is a fantastic choice if you're an absolute beginner, mainly because it actually comes pre-installed right alongside Python itself. It's super lightweight, distraction-free, and lets you start experimenting right away. But if you want a tool that's really going to grow with you, PyCharm and VS Code are the industry heavyweights. PyCharm, specifically the Community Edition, gives you this deeply structured, powerful setup right out of the box. It's perfect for guided learning. VS Code, on the flip side, is just incredibly flexible. It's highly customizable through thousands of different extensions, which makes it a huge favorite for developers who love to tailor their environment exactly to their own workflow.
Once you've picked your editor, you've got to actually install Python. The steps here are pretty universal. Download the latest release for your operating system directly from python.org and run the installer. Now, for Windows users, pay close attention to step 2. It is absolutely crucial. You literally must check the box that says Add Python to Path. Why? Well, adding Python to your path modifies your operating system's environment variables. It essentially tells your computer's brain exactly where the Python language lives on your hard drive. This is what allows you to run Python commands from any terminal window anywhere on your system. Skip this, and your computer will just throw an error. Finally, you just open up your terminal, type in Python 3-version, and when you see that version number pop up, you, my friend, are officially ready to code.
Moving right along to part 2, core syntax and functions.
Think about this for a second. How does Python actually make decisions? When you build an application, it can't just run a single, static, straight line of code every single time. A static script like that is virtually useless for real-world tasks, right? It needs to react. It has to make choices based on user input, changing data, or specific triggers. Interactivity is the whole name of the game in programming. So, how do we actually orchestrate that logic?
Python handles all this interactivity using what we call control flow tools. The primary decision maker is the if statement, which branches out your logic. If a condition is true, it executes one action. Elif, which stands for else if, gives it another option, and else catches absolutely everything else that falls through the cracks. Then we have iteration, which lets us repeat actions. A for loop in Python is brilliant because it iterates directly over the items of any sequence, like a list of numbers or characters in a string. It's vastly cleaner and way more efficient than those traditional index-based loops in older languages where you have to manually track counting variables. And a while loop? Well, it just keeps running continuously until a specific condition is no longer true.
Now, a relatively modern addition to Python's syntax is the match statement. If you've used switch statements in other languages, this concept might feel kind of familiar, but it's actually much closer to the powerful pattern matching you'd find in a language like Rust. It takes a subject value and compares it against successive patterns in case blocks. And the reason this is a total game changer is that it immensely cleans up your code base. Instead of writing this massive, messy wall of if and elif statements to handle 10 different possibilities, pattern matching handles complex conditional logic cleanly, efficiently, and in a highly readable way.
We also need a way to organize our logic into reusable blocks, and that is exactly where functions come in. Introduced by the def keyword, code reusability is a massive, massive principle in programming. Instead of copying and pasting the exact same logic over and over, you define it once. You can pass parameters into these functions. You can even set default argument values, making them optional for the user, or use keyword arguments to explicitly state which variable you're assigning a value to. This is huge because it prevents bugs from passing arguments in the wrong order, and it actually makes your code self-documenting, right at the point where the function is called.
All right, let's dive into part 3, Object-Oriented Programming Basics.
Looking at the source material, there's an idea that really stands out to help demystify object-oriented programming, or OOP. As one developer noted, you don't actually have to use classes, but they are a massive convenience. Think of it this way. Just like you wouldn't throw all your physical files into a single giant messy pile on your desk, you shouldn't leave all your code scattered globally across a document. Classes basically act like a folder. They bundle specific data and functionality together to keep related items neatly organized and super easy to manage.
To break it down technically, a class is the blueprint. It defines what attributes and methods an object will eventually have. An instance, on the other hand, is the actual, concrete object you build from that blueprint. So if your class is the general concept of a car, specifying that it needs wheels and an engine, the instance is the actual, tangible red sports car sitting in your driveway. This separation is exactly what allows software to scale up to millions of users. You can create millions of unique instances from a single class blueprint, and their individual data will never collide.
Inside that class, we use a special method called __init. This is the constructor. It automatically runs the very moment a new instance is created, seamlessly setting up its initial state. And then there's the self parameter. Self is simply a convention that allows the object to reference itself. When you use self.name or self.color, you're ensuring that the data belongs uniquely to that specific instance. It basically guarantees your red sports car doesn't accidentally overwrite the data of your friend's blue sedan.
This brings us to part 4, PEP 8 coding style.
Writing functional code is great, sure, but writing readable code, that's what makes you a professional. A messy piece of code might run, but it's an absolute nightmare for anyone else to read. That's where PEP 8 comes in. It enforces strict aesthetic rules to make Python universally readable. It even definitively ended the infamous tabs versus spaces debate among developers by mandating exactly 4 spaces for indentation. Why? Because tabs cause formatting chaos across different editors, whereas spaces are always consistent. We also limit lines to a maximum of 79 characters, which means multiple files fit nicely side by side on your monitor. And for naming, we use snake case, that's all lowercase separated by underscores for functions and variables, and Pascal case, where every word starts with a capital letter for classes. Trust me, adopting this style early on is absolutely one of the best habits you can form.
Finally, part 5, building Python applications. Let's take all of these theoretical building blocks we've talked about and actually construct a real-world application. A command line calculator is the quintessential first project. We start by capturing the flow of data right from the user's keyboard. We use the input function to ask for a number, and we wrap it in intine so Python knows, hey, we're performing math on an integer here, not just reading text. Second, we ask the user to choose a mathematical operator. And finally, we feed that input into an if-else control flow structure. If they typed a plus sign, we route the data to an addition block. If a minus, we subtract. It's just simple, layered logic, creating a fully interactive tool.
Now, by wrapping our entire calculator logic inside a while true loop, we create a persistent program that runs endlessly. Then, we add a try except block. This essentially tells Python, try to do this math, but if you hit an error, like say the user makes a typo or tries to divide by 0, don't crash, just print an error message and loop back to the start. This mimics how real professional apps work. They don't just close out and disappear the moment you press the wrong button. This right here is exactly how you create robust, unbreakable software.
And the beautiful part is, these exact same concepts apply to almost anything you want to build. Want to create a persistent to-do list application? Easy. You just use variables or lists to store the user's daily tasks, a while loop to keep the main menu persistently running on the screen, and if conditions to evaluate whether the user wants to add a new task, delete an old one, or just view their current list. Functions, loops, and conditions. These are literally the atomic elements of every single interactive application out there. So, we've explored the environment, the coarse syntax, the incredible organizational power of classes, and the exact logic you need to build actual applications. You now have the fundamental blueprint for Python programming in your hands. The only question left to answer is, what are you going to build next? Grab your preferred IDE, start experimenting with the code, and just let your curiosity lead the way. Thanks for joining me on this explainer, and happy coding.